2010 connected particles question is a wedge with two particles on it. A smooth wedge of mass 4m and slope 45 rests on a smooth horizontal surface. Particles of mass 2m and m are placed on the smooth inclined face of the wedge and the system is released from rest. Show on separate diagrams the forces acting on the wedge and on the particles. In part 2, find the acceleration of the wedge. Okay, let's look at the forces at play here. Let's look at the wedge first. So we've got two ores in this question. We'll call them R1 and R2 between the particle and the wedge. R1 and R2. It's 4m, so we have 4mg coming down. We also have this reactionary force between the wedge and the smooth surface, which doesn't come into the question, but we'll call it S. And we have our 45-degree angle. Okay, so the key with the questions like this is the acceleration of the particles, which we'll do in the next part. Let's look at 2m. So we have 2mg, 45. That line is supposed to be straight. We have a 45 in there. So we have 2mg cos 45. And coming in this direction, parallel to the slope, we have 2mg sine 45. We have R1 coming this way. This is the one on the lower side, this R1 here. And that's the forces. We don't need to solve them or work anything out yet. So let's have a look at the M. We have our 45. Straight down, we have our mg. In this direction, I have mg cos 45 because you all know it's adjacent to the angle and coming in this direction, parallel to the slope. Opposite the 45-degree angle is mg sine 45. And we call this R2. So there's no friction involved here, so let's have a look at the equations then. So we start with the wedge. We didn't put accelerations in actually in the first one. Now what do we call them? Let's call them P. P for the wedge and Q for the particle. P and Q. Okay. So with the forces acting on the wedge, we know it's going in this direction. So we got to get the forces acting in that direction. So if we have R1 here, going to the right is going to be, on my 45-degree angle in there, it's going to be opposite the 45. So it's going to be R1 sine 45. And you can see here, this one here, you've already set up this equation. This is R2. So you should be able to see that going in this direction. We also have, if I drop a line straight down from it just to be consistent with our work, it's going to be in that direction, R2 sine 45. So we have two forces pushing this wedge to the right. So my equation then is R1 sine 45 plus R2 sine 45 is equal to MA, and the M is 4M, so 4M, and the A we called P. So let's get the equations of the particles, but let's first look at the accelerations. So this is the slope. We have the acceleration of the wedge moving in this direction at P. This is 45. So if we create a right angle here, because this direction is going to be the same as this one that I'm coloring in here in red, and we need the acceleration in this direction also, which is going to be, what do we call it? Q. It's going to be Q minus whatever's going on between here and here. So you know that this is P adjacent to cos 45, and this is P opposite the 45 sine 45. So these are my two accelerations. Q minus P cos 45 going down the incline, and P sine 45 coming down in this direction here. So let's set up my equations. Let's go in this direction first. So the forces in this direction are this one. So we start with 2m going down in this direction. We're going to get 2mg sine 45. Nothing stopping it. So that's going to be equal to the mass, which is 2m times the acceleration, which we said was this guy here, q minus p cos 45. We can multiply that out. We can divide by 2 first. So we're going to get mg over root 2. Can we divide by m as well? We can actually divide by m as well. So we're going to get g over root 2 is equal to q minus p over root 2. So that's the first equation for 2m. Let's look at this direction here, the R1, and this direction here. So we're starting with this direction going down this way. 2mg cos 45 minus R1. 2mg cos 45 minus R1 is equal to m, 2m, times a, which is this a here, p sine 45. So again, we can not divide by 2m in this case, so let's just simplify it down. 2mg over root 2 minus R1 is equal to 2mp over root 2. I'll just put a box around these, tidy it up. We've got these two. We've got this one over here, can be tidied up as well. So I'll just change to blue. Or 1 over root 2 plus R2 over root 2 is equal to 4mp. So R1 plus R2 is equal to 4 root 2 mp. Need to form an equation for my m as well. Here's my m. So m is going down in this direction. So I'm going to get mg sine 45. But actually, maybe I should just take, I need my r involved. That's not going to give me an r. I'll take it in this direction and this direction. I think that's a better way to do it. So mg cos 45 minus r2 is equal to m, which is the mass times the acceleration up and down in this direction, is p sine 45. This one here. Tidying this one up, we're going to get mg over root 2 minus r2 is equal to mp over root 2. And I don't think we need the other one. I think these are enough equations. Let me just rewrite them down below and we'll tidy them up. So I bring this one down here. We can eliminate our r2, so we could say that r1, and that will give me r1 just in terms of p. So we should be able to then sub that in there, I think, and solve this question down. Let's say, does this work? R1 plus mg over root 2 is equal to 4 root 2 mp plus mp over root 2. So R1 is equal to, let's simplify this, and 4 root 2 plus 1 over root 2. That'll give me 9 root 2 over 2. So 9 root 2 over 2 mp minus mg over root 2. And if I sub these in up here, if I sub R1 up here, I'm going to get 2mg over root 2 minus R1. So that's minus, well, I'll do the plus this one first, plus mg over root 2, and it'll be minus 9 root 2 mp. But maybe just bring that to the other side and write 2 mp over root 2 this one, and I'm bringing the minus version of this over, so plus 9 root 2 over 2 mp. So cancel my m's. So I get 2g over root 2 plus 1g over root 2 is 3g over root 2. And that's going to be equal to 2p over root 2 plus 9 root 2p over root 2. So type in 2 over root 2 plus 9 root 2 over 2 into a calculator. It's going to give 11 root 2 over 2. So it's going to be p times 11 root 2 over 2. And if I divide 3g over root 2 by 11 root 2 over 2, I'm going to get p. So typing this into a calculator, p becomes 2.672 ms to the minus 2. Just check, is that the acceleration of the wedge? Yes, p was the acceleration of the wedge, which is what they're looking for in this question. That's the end of this question.